Hi guys, welcome to my channel. I am a software engineer and I like solving coding problems and learn new technologies. I'm starting this channel to share my knowledge with others and help the community. I'll be creating videos on software development concepts and problems, and I hope that you like and subscribe to my channel. Today we'll be solving an easy code problem. Remove duplicates from sorted array. The problem statement is given an integer array nums sorted in a non-decreasing order, remove duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same and return k after placing the final result in the k slot of num. So k is basically after removing the duplicates, the size of the nums array is k, what k is representing here. Look at the example here. Nums equals to 1, 1, 2. Output is 2. So after removing the duplicate element 1, we are left with this array, and the size of this array is 2. Similarly, the input is 0, 0, 1, 1, 2, 2, 3, 3, 4. After removing the duplicates, the array looks like this, and the output is 5. So to solve this problem, two important things to keep in mind that is mentioned in the problem statement as well. One, we have to solve it in place. We have to modify the same array to return the result. We are not allowed to use any extra space. So what does it mean? That we cannot use a brute force approach of taking each element, keeping it in a hash set, and then returning the size of the hash set. That will not work because we have to solve in place. We cannot use any extra memory. And second is this is a sorted array, which means all the similar elements will be placed together, like all the zeros, all the ones will be placed together. So what we can say is all the duplicate elements will be placed next to each other. So to identify which are the unique elements, what we will do here is we will compare the element to its previous element. If they both are same, that means they are duplicates, and we will keep on doing until we find a unique element. So what we will use here is two pointer approach. One pointer will be used for traversing the array, and second pointer will tell us the position where we have to place the next unique element. So let's say I'll first solve the problem and then I'll explain how it is working. So I'm taking first pointer j equals to 1, and then I'm taking another pointer I, which will be using for traversing the nums array. Nums dot length, right? And what I'll be doing is I'll be checking if nums of I minus 1 is not equals to nums of I, and then nums of j plus plus equals to nums of I. So j is the pointer which which is used to hold the position where we will be putting our next unique element. So the position 0 is already like having the unique element. So let's forget about that. We are assuming that at position 0, the element itself is unique. So next unique element will come at position 1. So that's why we are starting it with j equals to 1. Why I is being started at 1? Because we are using nums of I minus 1 not equals to nums of I here, and I minus 1 will be point to 0 here. If we will start it from 0, it will give us array index out of bound expression because 0 minus 1 will be minus 1, and minus 1 is not a valid index, right? And yeah, just like that, we will return our value j. So to show it, uh, I'll have created this. So I is 1, j is 1 initially, and nums of I minus 1 is not equals to nums of I. But this condition is true, and this condition is false in this case, so nothing will happen. We will, our I pointer will move to the next position. I is equals to 2. Now I minus 1 and I are actually not equal. So condition has become true. So if you see here, nums of 1 is not equal to nums of 2. So actually 0 and 1 are not equal. The condition is true. Now our next statement will come into picture, which is nums of j plus plus is equals to nums of I. So basically, whatever value we have found at nums of I, which is 1, we will place it at this position which j is holding for us. Like next unique element will come at this position. 1 is an element, we'll put it here, and we are incrementing j plus plus so that now obviously we have placed the 1 at the right position. Now we will keep our pointer to the next position, take our pointer to the next position where the next unique element will come, right? So now j equals to 2, and now again I is equals to 3 and I minus 1, they are both 1, so condition is false. Again condition is false. Now when I is equals to 5, then nums of 4 is not equals to nums of 5, right? Clearly 1 is not equals to 2, right? Condition is true. Now 2 is our next unique element, which we have to place it at this position, which j is having, j equals to 2, right? So now we have put it at j equals to 2, but we will keep on doing this until the end of the array. Now I is 6, condition false. Now I is 7. Now again 2 is not equals to 3, condition is true. Now 3 we will take up and put it at the position which j is holding, j equals to 3, right? Similarly, I equals to 7, I equals to 8, condition is being false. When I is equals to 9, 4, it is at position 4, like now it is having 4. We will keep our 4 to the j equals to 4. We'll take that element there, 0, 1, 2, 3, 4. Now if we see, all the unique elements are at the start of the array, and j is at position 5, which is also the size of the array. So 0, 1, 2, 3, 4 is like having total 5 elements. So that is our going to be our answer. So we will come back here, we will return j, we'll try to run it. Yeah, it is having accepted. Let's submit it. Yeah, now this is done. I hope I have helped you understanding the problem better. If you like my efforts, please do like and subscribe my channel. It will encourage me to create new content. Thank you.